Hi, welcome to another Algebra 1 video. This is section 2.4, which is solving multi-step inequalities. In this video, we will learn about solving multi-step linear inequalities, and we will also learn how to graph solutions to multi-step inequalities. So let's begin with solving multi-step inequalities. Before we solve some inequalities, I will go through some rules that we should remember when you're solving inequalities. We know that to solve inequalities, it's just like solving equations. We will use the inverse operations of addition, subtraction, division, and multiplication to solve inequalities. In the previous videos from the properties of inequalities, we also learned that when you're dividing or multiplying by a negative number, you reverse the inequality sign. For example, if you have the original inequality sign, less than, then you would swap it to greater than when you're dividing or multiplying by a negative number. And similarly, if you originally had the greater than sign, then you'd switch it to the less than sign. And finally, for the other two, if you had the less than or equal to sign, then you'd swap it to the greater than or equal to sign. And finally, if you had the greater than or equal to sign in your original inequality, then if you divide or multiply by a negative number, that sign will flip to less than or equal to. So let's begin with number 1, which says that 4b minus 1 is less than 7. So I see here that I can use the property of addition to get rid of that negative 1 here, and I can add 1 on this side of the inequality. So if I do that, I get 4b minus 1 is less than 7, and then we do plus 1 on each side of the inequality, and we can cancel out the negative 1 and the plus 1 here, leaving us with 4b is less than 7 plus 1, which is 8. And now I can divide each side of the inequality by 4 using the property of division of equalities, and we get 4b over 4 is less than 8 over 4, which gives us b is less than 8 over 4, which simplifies to b is less than 2. So b is less than 2 is the answer to this inequality. Now let's graph this inequality we solved on our number line. So by looking at the inequality that we solved, we got b is less than 2. And I know that one of the critical points is 2 because it's included in the inequality. So I can mark 2 over here, and we can place an open circle. But now let's see if it's going to be an open circle or a closed circle, which is going to be filled. Well, I can see that it's a less than 2 sign, so it's going to be an open circle. And since it's less than, it's going to be in the negative direction, as numbers that are less than 2 are in the negative direction. Here's another inequality which says that 6 is greater than or equal to 5 minus b over 3. In this inequality, I can see that 5 is being added to negative v over 3. So I need to get rid of that 5 to isolate this v over 3. And I can do that by using the property of subtraction. So if I subtract 5 from each side of the inequality, I get negative 5 on this side and negative 5 on this side. And we can get rid of that 5 and negative 5 on the right side of the inequality. And here 6 minus 5 is simply 1. So we're left with 1 is greater than or equal to negative v over 3. Now I can see that the term of v over 3 has a negative coefficient, a coefficient of negative 1. So if I need to turn this into a positive, I will have to multiply or divide it by some negative number, which will cause us to flip this inequality sign. So if I multiply each side of the inequality by negative 3, I get 1 times negative 3 is greater than or equal to negative v over 3 times negative 3. And here my 3's cancel out, and negative times negative is positive, so we get v over here, and we flip the inequality sign. And here we simply get negative 3. And we can rewrite this inequality as v is greater than or equal to negative 3. Now let's graph this inequality on a number line. So from this inequality that we solved, I know that my critical point is negative 3, as v is greater than or equal to negative 3. So negative 3 is part of the solution for all values of v. So I can mark negative 3 here and circle it, which is filled because negative 3 is part of the solution. And now the second part is, do I extend the ray in this direction or this direction? Well, here v is greater than or equal to negative 3. So the greater part tells us that it's negative 3 and the values that are greater than negative 3, which is in the rightwards direction. Here's another inequality which says that 5x minus 12 is less than or equal to 3x minus 4. In this inequality, I can see that I have the variables of x on both sides of the inequality. So to get rid of the variable on one side and to bring all the variables on one side of the inequality, I see that I can subtract 3x from this side and this side. And by doing so, I get minus 3x on each side of the inequality. And here we can simplify the 3x and the minus 3x, leaving us with negative 4 on the right side of the inequality. And here 5x minus 3x is 2x, and then the negative 12 is brought down, and we're left with 2x minus 12 is less than or equal to negative 4. Now in this step I see that I have that negative 12, and I have to get rid of it so I can isolate the variable. So I see that I can add 12 on each side of the inequality, and by doing this we get the negative 12 and the plus 12 cancelled out, leaving us with 2x on the left side of the inequality. And here we have negative 4 plus 12, which is 8. And now I can divide each side of the inequality by 2, which leaves us with x is less than or equal to 4. And this is the inequality solution. Now let's graph the solution on a number line. So based on the solution that I got, I know that my critical number is 4, so I can place a 4 somewhere. And I know that 4 is part of the solution because of the less than or equal to sign, and that equal sign tells us that 4 is part of all solutions of x. So I can place a closed circle, and it's less than 4, so I can take the ray from here to the leftwards direction towards the negative numbers, as the negative numbers are less than 4. Now this isn't the end of solving multi-step inequalities. It happens so that when you're solving some multi-step inequalities, you end up with some special cases. Instead of revealing you those special cases, I'll go through some problems that will reveal those cases so you can understand in what cases these cases arrive. So here's case 1. We're given that 2 times k minus 5 parentheses close is less than 2k plus 5. So here I see that I can distribute this into 2k minus 10, and then this is less than 2k plus 5. And now I can get rid of this k over here, so I can bring all the k's on either this side or this side. So I'll subtract 2k from this side and this side, which will leave us with nothing left here as of k and here. So we have no k's on each side of the inequality. And then we're only left with the constant, so here we get negative 10 is less than 5. So in this case, we're not left with any variable. All the variables have been eliminated. We have no variable terms, so we can't solve for a specific variable. Well, it turns out that this inequality that we just ended up with, which consists of no variables, is true because negative 10 is less than 5. So this is a true statement, meaning that all values of k will satisfy this inequality. And so the numbers of k that satisfy this inequality consist of all the real numbers. This is the real number sign. So this consists of all the negative numbers all the way to negative infinity, and all the numbers towards positive infinity, including 0, and also including all the decimal numbers that are in between. So in case 2, we're given that negative 4 times 3n minus 1 parentheses closed is greater than negative 12n plus 5 over 2. So on the left side of the inequality, I see that I have a coefficient of negative 4 being multiplied to this whole term in the parentheses. So I can distribute this term, giving us negative 12n, and negative 4 times negative 1 is plus 4, is greater than negative 12n plus 5.2. And now using the property of addition, I can get rid of the variable here or here to bring all the variables on one side of the inequality. So I can add 12n on this side and the left side of the inequality, and I can cancel out this, but over here all of the n's also cancel out, so we're left with no n. Let's see if this is going to be an all real number solution. So we're left with 4 is greater than 5.2. Well, I can see that this is not a true statement because 4 is not greater than 5.2. 4 is less than 5.2, so this is false. So because this inequality that we ended up with is false, and we ended up with no variables to solve for, we can say that this inequality has no solution, or we make this symbol which means no solution. So we know that the two cases that we arrive at are, you can either get all real numbers if the inequality you end up with is a true inequality, but if you end up with a false statement when solving for inequalities, then that means you have no solution. And this is it for section 2.4. I hope you found the concepts of solving multi-step inequalities useful either when you have variables on one side or both sides of the inequality, and how you can also solve inequalities when you end up with special cases like this one and this one. Also leave a comment and provide feedback so I can improve my videos in the future. And I'll see you in the next video. Thanks for watching.